Hi, we're going to go over some of the answers to the using energy bars to track mechanical energy. Let's do scenario 1. Okay, here are the key things. Okay, a car is released from rest, so we know that at A it has no motion. And then, although I should have made it more obvious, it's on its own because of the slope. It begins to move. At B it's halfway down and moving. And at C, it's all the way down to its low point and moving at its fastest. And we are supposed to ignore drag and friction effects. So what do we have at A? Let's go through our energy analysis. Okay, there's no kinetic because there's no motion. There is gravitational potential because the car is elevated from its lowest point. And there's nothing squished or stretched, and so there's no elastic potential energy. Okay. Now, what is the sign? What is the meaning of this equal sign as we transition, as the system transitions from A to B? Well, what that's saying is that we don't see any evidence. Really, there is no work being done on the system or by the system, and so that tells us that the total mechanical energy in the system must be constant, and so that is the purpose of the equal sign in this energy flow diagram. So that means that the energy in B, whatever its form, has to be equal to the energy at A. So it's halfway down, so it's going to have half the gravitational potential energy that it did before. Okay, so that's 2 blocks. We have to say, okay, well, where did the other 2 blocks go? And we're going to see that the car is moving, so it's now kinetic energy. Okay, again, as we transition, hey, it's moving on its own. Okay, well, anyway, as it transitions all the way down to C, there is no work done. So we need to have 4 blocks total in C, because we had 4 blocks at B and 4 blocks at A. And now, of course, we see that it's at the lowest point it's going to go, so there's no gravitational potential energy. There's no elastic potential energy. There never was. Okay, why is there no dissipated energy or mechanical energy going into thermal energy? Because we have no drag or friction. At least we're saying they're negligible. So that means all 4 blocks are going to be kinetic energy. Okay, scenario 2. We have a ball moving along a carpeted surface. Okay, why carpeted? Because there's going to be friction. That's why I put it on a carpeted surface. Okay, and we are to begin. So what we see is that the ball is moving from A to B to C, and it slows down to a stop. We're supposed to begin our analysis after A is already moving, so we're not looking for anything that did work on A. It's already happened. Something in the past has already got the ball moving, and now we're just going to take it for what we see. We see a ball at A moving. So that means, typically I will pick 4 blocks for almost any scenario, and it's really not important at this point. We can cut blocks in half. We can cut them. It's just ideas. There's a certain quantity of energy in our system at A, and it's going to be all kinetic, and I'm just saying it's 4 blocks. Now, as the floor is slowing down, as the ball is slowing down, we see that a lot of its energy now has gone, that mechanical energy, that kinetic energy has now just gone into heat energy, and now it's dissipating out into the universe. The ball's gotten warmer, and the carpet's gotten warmer, and all that heat is going to just work its way in all directions, and that's why we use the term dissipated. And at C, we can see that there is no motion whatsoever, and so all of the energy is going to be dissipated. Okay, we're going to stop there. That's number 1 and 2, and we'll continue the remainder in a separate video.